Hey, everybody. I'll just give a few more minutes for folks to join. And in the meantime, let me also share my screen. Also, Richard, let me know if you can uh, join as a panelist as well. I think I made you a panelist, but I'm not sure.
I appear to be Richard Blytheman today. Not sure what's up with that.
That is quite funny.
So the issue was that I think the invite link that was provided is an invite link that has his metadata in it, and he didn't set up some sort of automatic invite system.
Oh
Wow.
no.
Well, this is going to be very confusing for the recording to see so many clones of Richard, but I think we'll make do.
Yeah. I don't know if the actual Richard is here. I tried messaging him earlier today because his Discord has been pretty silent. I'm like, what's going on here? And I was like, yeah, I'm going to be in Europe, so you want to hang out? So I don't know. I haven't heard from him yet, though. That was like a day ago.
Yeah, I also didn't hear from him since yesterday, but he did say yesterday that he would be able to join. So we can probably get started. Maybe do all of the folks who are joining as Richard want to introduce themselves? Then we can kick things off.
Hey,
Oh,
what's up?
there he is. Hey, Richard.
Sorry I'm late.
No worries. There just seems to be some interesting quirk in our Zoom webinar where everybody seems to be Richard today.
Oh yeah, this happened last time as well, I think. Yeah, last
Yeah,
time
will the
everyone
will the
was
real
Richard.
Richard Blytheman please stand up?
Hello, Chris.
So I think it's related to the link or something. But
Okay, we'll sort that out.
You can update the meeting and push the change to everyone.
Okay. We can probably do that for next time, just so we don't spend too long figuring this out. I actually can find this pretty funny, so I'd love to roll with it.
yeah, it can be a new thing that we do every call. Maybe, who knows?
Yeah.
Would the real Richard Blythe please stand up? Please stand up.
Yeah, I love that.
Awesome.
But also, Sarmad, I don't think you've met Kyle before. Kyle is working with the tech team at NAFTA, and we can demo something today related to MCP. I think I might have told you before, Sarmad, that we worked on the streamable HTTP plus OAuth reference implementation, which didn't exist before.
Right.
So Kyle can demo that. And then we also have been working on auth for we've been thinking about how to like embed auth into different apps and that sort of thing. And Kyle has a demo. It doesn't use MCP, but it's also like quite easy to imagine how it would use MCP.
Yeah.
And it would be a cool thing to discuss and get people's thoughts on. And then
Yeah.
Kyle Sarmad has been working on MCP for a really long time, created like MCP agents, and also recently has been running on stuff like async long-running processes using MCP, which I'm sure you'll be interested to hear about. So
Yeah,
there's a bunch of
that
stuff we can.
sounds super awesome.
That sounds great. Actually, I think auth and maybe like agents represented as workflows and long running tasks can be two of the themes that we cover today. And then if others on the call have any other demos, we can probably like leave some time towards the end for that. So just maybe like use the Q&A section to flag that, and we'll make you a panelist. But yeah, Kyle, do you want to maybe start with the auth side of things? I'd love to see what's going on, and also maybe share with the folks on the call kind of the background and motivation for some of this work.
Yeah, so we actually, I guess there's a couple different things we could talk about. I think the first one is something that we built in response to a Cloudflare blog post, which if you're in the MCP world, you have probably seen. It's about basically deploying MCP servers with Cloudflare workers using the server-side event standard and the authorization specification that was added to the MCP spec, which I've read more times than I care to admit. So I can go ahead and drop a link to that blog post in the chat. Let's see. Yeah, there it is. Yeah, just look for the message from Richard Blytheman in the chat. It's in there. So
This guy's really smart.
yeah, he's so many places at once. So in their blog post, I mean, they talk about a number of things. They implemented the server side event standard, which is a way that you can, host MCPs over the network. But there are lots of things about the SSE standard that are not great. It's super stateful. You can run into like proxies and load balancers buffering things. A lot of clients don't have great SSE support. Like Cursor, for example, will tends to time out SSE connections periodically. And so the other problem is if you're going to host it on the internet, you need authorization. And so what Cloudflare did is they said, hey, there's this new authorization specification for MCP, which is basically, if someone tries to connect to an HTTP based MCP server transport, you can return a 401. And then it can go and pull a bunch of information from the server, which implements like a dynamic metadata URL. So I can pull that part of the spec up too. Authorization. So this is the basic authorization. So in short, the MCP server can actually implement a bunch of like OAuth related functionalities, including a metadata URL that says, here's where the URLs are for things like the dynamic client registration, which is part of an OAuth protocol extension and a number of other things. And so the client can actually use that to initiate the OAuth flow with the end user to do OAuth with the with the MCP server. The client, so that would be your Cursor instance or your Quad desktop, will dynamically register itself as an OAuth client with its own client ID and secret. And the reason for this is because otherwise, whoever hosts that MCP server would need, to issue you credentials and all of these things. And so dynamic client registration is a really important part of it. The server has to implement it. And so like the standard has all this great stuff in it, and nobody implemented it except Cloudflare. And Cloudflare's implementation is great, but there's a couple things that we weren't big fans of. One of them is if you're not building on Cloudflare, you can't use this example. It's super opinionated about workers and durable objects, and they have a ton of tooling around it, which is great if you like building on Cloudflare. Some of us like more portable environments and applications. And so we set out to build an implementation of an OAuth compatible MCP server using um, just normal like JavaScript stuff, like using Express is what I use. So anywhere, you can run a Node.js server, you can run this. we ran into a bunch of interesting challenges, and one of them is that the OAuth tools that are in the Model Context Protocols SDK for TypeScript like are not complete and are actually broken. Like they hard code, for example, redirect URIs for the dynamically registered OAuth clients, which is really bad because it means, if your app isn't using it, like isn't using the port it's expecting, it won't work. Um, so I ended up having to, and I can walk through the code here in a bit, but I ended up having to subclass a lot of the implementations of things that were in the SDK and then using those subclasses in my code to get it to work properly. The other problem is that right now, most MCP hosts don't support the authorization standard. So if you plug in an SSE URL that returns a 401 in compliance with the authorization standard for the MCP or for the MCP spec, like it'll ignore it. Like it won't work. And so that's another question is how do you use MCP servers that require authorization from Cursor or from Cloud Desktop? And then finally, the streamable HTTP transport is awesome and everyone should use it instead of SSE because it's way better. It can be stateless, so you could deploy it on a serverless environment. There's lots of great reasons to love it. But also no clients or hosts support it yet, which is really funny. There's Python implementations of like the WebSockets transport, which isn't even an official transport. But for the longest time, there wasn't a Python implementation of the streamable HTTP transport, client or server, which is frustrating. Cursor Cloud Desktop didn't support it. And so the question is, okay, well, how do we use this really awesome transport, which everybody should use? And how do we get authorization with an MCP server like working? And then how do we plug that into a client because clients don't support it? And so there were all these problems. And it turns out we were able to piece together a solution for it. Someone's raising their hand. Yeah, go ahead.
Richard, go ahead.
So I was going to wait until you were done with the whole presentation before I spoke about the things that I've been thinking about with regards to authorization. So can you please find a good spot to finish, and then I'll reflect upon what you said.
Yeah. Okay. Yeah, so let me pull up my cursor and everything, and I'll set up a screen share. Hopefully I don't get stuck in the screen share because it happened this morning because I'm not used to Zoom. So let's see here. I'm just going to share my entire screen. Okay, can everyone see that?
Yep.
Okay, let me not share my environment file. So this is the implementation of the server, which is just kind of an Express app. It actually implements both the SSE and the streamable HTTP transports. Unlike an SSE transport, when you're setting up a server, like you this is an example server. You define your server and then you do like you do something like this, and then you'd run this file or specify in your mcp.json file, like um, like bunserver.ts, and that will set up the transport and connect everything, and you're good to go. For the streamable HTTP and the SSE transports, you actually need a server that accepts new connections, creates the transport, stores it in memory because there's connections related to it, so you can't page it out to a database. And so you need a whole app instead of just kind of a single file. And so this Express app uses the my extension of the OAuth proxy provider. So the MCP SDK has a class that basically lets you proxy to an upstream OAuth provider. There's a couple problems with this, and one of them is that the upstream OAuth provider you're proxying to needs to support dynamic client registration because the version in the SDK could implement dynamic client registration in its own like OAuth functionality instead of just proxying that upstream, but it doesn't. So your upstream provider has to support it. Google and other popular OAuth providers do not support dynamic client registration for a lot of good reasons. And so you need to use something that does, or you need to extend their proxy server so that dynamic client registration is handled in your proxy server, and then it's kind of proxying the other behaviors like the actual authorization to Google. There's other things here like you need to store the information that's returned in the client registration process, which their implementation doesn't do. So I had to do here. I defined like an in-memory store and also just a Redis store if you like persistence. And then, yeah, there were some other things that were broken that I had to fix. This is open source. Just really quick, it's at the NAPFA GitHub. It's like HTTP OAuth MCP server. There's lots of documentation about what it is, why we did it, how you can set it up and run it. And so implementing all of that was kind of tedious. You have to define a couple things like how do you verify an access token and how do you get a client? In this case, using my Redis store. You have to add middlewares so that if an unauthorized request comes that doesn't have an access token that was issued by your proxy, not by the upstream provider, because you don't want the upstream provider's access token being accessible to the client because the client could abuse it. So you want to issue your own access token, check for that, and if that's not present, return a 401, which should, if the client obeys the MCP standard, which none of them do, initiate the OAuth flow. And then, so you can see there's an SSE implementation here, but also the streamable HTTP transport is here. This is all, I don't want to say that this is trivial, but it's reasonably well documented, so I won't go through it too much. So the next problem that we kind of had to solve was, after we had extended and fixed all the OAuth provider stuff that the SDK didn't provide, is how do we actually get this plugged into Cursor? And so one of the guys at Cloudflare wrote this great NPM package called MCP Remote, which basically proxies an arbitrary SSE or streamable HTTP or even WebSockets transport. I think I don't remember if it maybe not WebSockets, but proxies it to a standard IO transport. So it essentially creates a standard IO transport. Like this is how you would set it up in Cursor with running MCP Remote directly. You specify the remote URL. You can specify headers and stuff if you want to. You don't need to. Like if you're using the OAuth standard, it's not necessary. And then like it'll establish a standard IO client with the Cursor host, and then it will establish an SSE or a streamable HTTP transport with your remote server. The cool thing about it is that it supports the authorization standard. So if that remote transport returns a 401 code, instead of passing that code on to Cursor, which doesn't know what to do with it, it will launch the OAuth process for you and prompt you to authorize. And then, you complete the authorization process and then it'll carry on and it'll do all of that transparently to the MCP host. So it thinks it's just talking to a standard unauthorized MCP server. So I can try and give an example of what that looks like. So I have, let's see, where's my mcp.json? This is an example of it. I'm just running the MCP remote package with the URL to my my Express server and index.ts here, which is listening on port 5050. /MCP is the route that the streamable HTTP transport uses by default. So I stuck with that. And then I'm telling it, hey, try the try the streamable HTTP transport first. Whoops. Try the streamable HTTP transport first, and if it doesn't work, fall back to SSE. And then in your Cursor settings, you would just toggle that on or off. Yeah, it's not. Let me make sure I have my Redis server running and the server running, Docker Redis server. So when I connect that, it should launch. Yeah, it launches an OAuth flow. In this case, we're proxying upstream to our Auth0 tenant. And the reason is that we actually did not want to implement dynamic client registration inside our proxy and then kind of proxy the upstream client so that Cursor's not aware of the upstream like client ID and client secret. So Auth0 isn't, if you're using it, you can specify whichever authorization providers that you want, like Google, GitHub, etc. But Auth0 lets you enable dynamic client registration. And so we were already using it. Oh, that's great. Live tech demos, man. Okay, well, that's frustrating. It looks like it worked.
So Kyle, I'm curious actually, like how did the OAuth flow get triggered? Was that something you did inside of Cursor, or is it just when you spawned the server process?
Great question. So, yeah, and so by the way, you can see over here that it did actually work. I just have my configuration messed up. But so when I connect the MCP server, like when I flip the switch, it sets up a standard, it launches like the MCP remote process, which establishes a standard IO transport, and then it connects to the upstream streamable HTTP transport. This was another thing that we had to patch, was that the streamable HTTP transport actually like doesn't make requests by default, like does the like SSE does. It establishes an SSE channel and then we'll stream events back to it. Streamable HTTP doesn't, and so until you make an API request, you don't know if you need to authorize. So we patched our implementation to immediately make a list tools request. They updated the official implementation to do this later. A lot of the things we built here were shipped within the next week by the team that was working on this. But so when the server returns a 401 from the list tools request, MCP remote actually is what handles popping open your web browser, and like asking the remote MCP server, hey, what is your authorization URL and all of that stuff. So like I could go to like this is the OAuth authorization metadata. So it tells it this is like the it looks up the authorization code flow. Here's the challenge method. Here's the token endpoint, right? So once you get like an authorization code, here's where you pass it to get a token. Um, here are the grant types and the registration endpoint for dynamic client registration. So MCP remote goes, pulls this from the MCP server that it's connected to, and then uses that to launch the OAuth flow. And in this case, it's using my upstream like auth 0 tenant. So issuer authorization URL, token URL, etc. I won't show you my environment file because it also has my API key, but it has all of that information from our auth 0 tenant. Does that kind of answer the question?
Yeah, absolutely. That makes a lot of sense. So it's basically like when the server is spawned, and so that's kind of a client-side behavior on when that is like gonna be when the server is gonna start up. It may be on startup of the MCP client, or it may be like when a MCP call is made to that server. And so like and then MCP report, what is the thing that actually like does the browser initiation request?
Yeah, so like the MCP server ideally is already running, right? Like conceptually, this is running in someone's cloud somewhere. And when your client connects to it, it'll tell you you need to authorize first, and then your client would handle, booting the authorization flow that I just went through. The MCP remote thing that we're using right here is like a stopgap method because right now clients don't support this, and so it's the thing that handles initiating the remote connection and initiating authorization, and then just kind of pretending that all that remote thing with all the authorization stuff is just a standard IO MCP server as far as your client is concerned. Now, Cursor and Cloud Desktop, the teams for both of those have both said they're going to support the authorization standard. They just don't yet, which is frustrating because it's been out since mid-March. But it's coming, we hope. I guess now would maybe be a good time to go back to the question that was raised earlier.
Okay. So I've been talking to some people about different things like MCP. I have concerns about things that are maybe outside of the scope of maybe just the authentication token sort of thing, such as like weird Unicode characters and prompt hijacking and all these, it's kind of a pain in the ass to secure. My thought has been a virtual file system really solves a lot of that with regards to your individual device. And with the whole IPFS virtual file system, having the hashing mechanism sort of isolates changes, because if a function inherits as arguments to other hashes or something, then you have to sort of replace the entire tree or the DAG tree of function, or that get called when you're calling functions. So that was the discussions that we had in the Yannick Discord server about how to be resilient against the prompt engineering attacks. Then with regards to the client-side authentication between MCP servers, I have been having discussions with some people from Protocol Labs, the libp2p, which apparently the libp2p people are way easier to get along with than the shipyard people, apparently. And there's, I know that there's a thing that the shipyard people bought into called UCAN, which is a type of decentralized ID where you can delegate permissions for different things. And that does seem kind of compelling. But the thing that this guy told me about from libp2p is the name like Dave Granatham or something. I don't know if I pronounced his name right, but he explains that like the DID solution is kind of not great because it doesn't have like a decentralized PKI. And without a decentralized PKI, it's not like a good long-term solution. And his thing, he's like trying to build something from scratch and write a PhD thesis, even though he's like, 40 in his 40s. And it's not anything that's been well publicized and battle tested, but I do think that there are definitely ways in which, like, if you had these decentralized network of MCP servers, that you could, something like UCAN makes a lot of sense, especially if you have a decentralized virtual file system to isolate the AI work that's going on from your main system. And that's been kind of my headspace lately.
Yeah,
one
I
more
would
thing.
say like, sure.
There's a guy at Red Hat who is interested in putting maybe MCP servers inside of cell phone towers. That's it.
Oh, interesting. Okay. Yeah, I would say I mean, there's been a lot of people talking about security model for MCP and like how do we protect against prompt injection and like how do you prevent the MCP server from doing evil things? And someone was like, man, I found this MCP server that people are using in Cursor and it's like reading a bunch of stuff off their file system it shouldn't. And on one hand, like it seems kind of like this really new novel problem, but it's really not. Like it's kind of the same security model if you think about it as like downloading and using arbitrary npm or PyPI packages. Like what it comes down to is you are either giving untrusted prompts to your LLM, um, and or you are running untrusted code on your computer. And so, like in either case, you have to trust that software, or and the authors of it, or you should not use it because at the end of the day, like it is very difficult to perfectly isolate MCP servers. I've seen some really interesting projects where they kind of throw it in a Docker container with, all the capabilities dropped and, establish transport doing some neat things. But, a Docker container is not a full VM. And so it still like is passing through your kernel. And so if you have a vulnerable kernel, you can still get kernel exploited, conceptually. So like that's kind of my thoughts on the security model is basically like if you don't know the authors or if you don't trust the source code, don't use it. Just like don't import random PyPI packages and use them, unless they're like popular and audited and trustworthy, because it's the same thing. It is, especially if you're using the standard IO transport, it's running on your computer. Or if you're running SSE transports on your computer, like you are running untrusted code. And so the only thing to do about that is to not run that untrusted code. If you're using a remote MCP server, like with streamable HTTP or SSE with authorization, it's still like roughly equivalent to that. And so you should still treat it with the same like security model in mind, which is if you don't trust it, don't use it. But there's not a good way to otherwise like guarantee the security of the system.
I think there's another question as well. Go ahead.
Or maybe not.
Is that you, Todd?
Maybe
Todd,
not.
are you trying to talk?
Yes. So someone just posted about a research position at Advanced Micro Devices, and the job is basically exactly doing the research paper I just started doing 2 days ago. I need a contact at AMD to get me a meeting with someone.
I'm afraid I don't know if anybody on the call can help with that. But if someone can, then feel free to use the Q&A. But let's keep the focus on
Absolutely.
the
This is
discussion.
very important. That's the only reason I interrupted. I'll put my contact in the chat.
Sounds good. Thank you. Kyle, I wanted to actually mention or ask a couple of things around this. One is around, I think, tool call authorization as well, and how you see the spec evolving from authentication of the server to like specific tools as well that may need to be authorized separately. And then the second thing around like threat modeling, you mentioned security modeling for just using, trustworthy packages from trustworthy or known publishers. I think there is an MCP server registry in the works as well as an open source thing. So how do you see the registry also playing a role, and how do you just generally think of authentication, not just at the server level, but also at the like maybe tool level as well?
Yeah, so authorization at the tool level is really interesting on a number of levels, and part of that's because there's a lot of different ways that you can do it. The approach that we're taking, which is proxying to an upstream Auth0 provider, doesn't give you a lot of flexibility for that. There are a lot of folks and the Stitch team, Stytch, their whole thesis is basically everybody needs to be an OAuth provider. And the reason for this is you need to, if you're going to have your own MCP server, when you have users connecting to it, and the MCP server says, hey, like, I want you to authorize me to use these capabilities. What you should actually be able to do, just like when you're connecting your GitHub to something and it says, here's a list of scopes that I would like, is you should be able to grant that MCP server some scopes, but not others. Now, that requires, again, that you are an OAuth provider, that you have your own definition of scopes that makes sense for your different capabilities, right? For example, for reading or for writing or at a fine grain level, you can do these specific actions in the platform, but not others. Scopes can be as granular or broad as you want, right? Think like read, write, execute. You could be 3 different scopes, or you could have like read some resource, execute some tool. Like it can be really granular or really broad, but there is a way in for example, with the streamable HTTP transport, you can check which tool is being called, and you can conceptually, define like a mapping of the different scopes that are required for each tool. And then, when the request is made, you basically check, does the access token that is on the request have the scopes that are required to use this tool? And then, if they do, then the server can make the tool call and return the result to the client. Because again, it's a private client at this point. We're talking streamable HTTP. It's up on the cloud. It's not running on your device. And so like the server can enforce access controls and authorization that way, like by scoping tools with individual scopes. So that's one way you could do it. There are, the other way is, you kind of, when someone connects to the server and lists the tools, you check the scopes that are on their token, and only like list the tools that token has access to run. And that's probably a better way because you don't want them to know everything they could possibly do if they don't need to touch those things. um so there's been a lot of conversations about that in the like working groups on this stuff. There is not like a universally agreed upon way to do this. It's such a new thing and it's so early that, for example, you won't find reference code on how to do that. Like you'd have to write that yourself. It's not terribly hard, but I didn't do that in the demo. So that's one way that you could do it, is you go be an OAuth provider and using Stitch or using something else. Maybe Auth0 lets you define your own scopes too. I don't know. I'm not that familiar with it, but like that's kind of how you would handle it. And that's another reason that I think um that the streamable HTTP transport is going to be really popular, is it lets you do things like that. And the standard IO transport, for example, doesn't support the MCP specs authorization extension. And so there's not a good way to do that. Streamable SSE, not really a good way to do that either. Sort of, again, just checking what scopes are present on the token and then listing only those tools at boot time. So I think that's like where it's going to move towards. That's not very well fleshed out in the specification right now. For example, what happens if you try and use a tool that you're not authorized to? Like, what response do you return that indicates the client it needs to then go ask you to reauthorize and grant additional scopes? We don't know. There's not a spec for that yet. To answer the question about registries, I think registries will go a long way towards building trust. But again, just because something's on the registry doesn't mean it's trustworthy. There's plenty of typo squatted packages on NPM and PyPI. There have been a number of headlines about this in recent years. I'm sure everyone here has seen. And registries actually had to implement controls to like prevent typo squatting because people were serving malware for, if you miss a key on a popular NPM package, you're getting an evil package. And so, finding packet like MCP servers that are popular and using those, or like published by a verified publisher where hey, this is the official Docker MCP server, or this is the official Google Drive MCP server by Google's team. Like that will go a long way towards building trust. I think just kind of the social proof of a registry saying, hey, this has like 2,000 monthly or 2 million monthly downloads. Like, that kind of helps security through consensus, although that's certainly not perfect. But it still is kind of the same issue, which is like if you can't trust it, don't run it. It's like anything in programming and computer security.
Very interesting. I think, yeah, and like you said, it's a fast-moving space right now as well. Lots of companies are trying to figure out auth for this. One of the things I wanted to chat about today, Richard, was also like agents represented as MCP servers, and in that case, authorization and authentication becomes even more important, especially at the tool level, because if an MCP server is not just calling like a single API, but actually doing something more sophisticated than on your behalf, then how do you make sure that like you gave it permission, the appropriate permissions to go about and doing that? So the scoping idea actually makes a lot of sense. Maybe I'll pick your brain afterwards about how to integrate some of those ideas into like an agent framework as well. So maybe we can chat separately. Yeah.
Yeah, I'm really happy you two met because, like, I'm sure you could chat for hours on this stuff.
I think so.
Sarmad about this stuff, and then obviously like talk to Kyle almost every day. So yeah, there's many conversations.
Absolutely. Richard, anything else that you wanted to showcase today as well?
Not really. I guess like just going over auth was like that's the main thing that we've been working on. Like I don't think as Kyle, I asked Kyle if he wanted to demo we were creating this embedded auth. So the idea with the embedded, so if you're using Zapier, for example, you need to like go to a third-party app to like manage all of your tokens and like go through the OAuth flow and that sort of thing. So one of our ideas was, should we have like an embeddable version, kind of like Pipedream, that is like that works well with like agents and MCP and all that sort of thing. So like yeah, I wonder like maybe just a quick question to you is if you wanted to do auth with MCP tools, like I guess first of all, like how would you want to do that? Would it be like embedded in your app or something like that, or do you think we're going to end up where we like navigate away to third-party sites to manage that? And also, how does this tie in with like agent experience? I guess because
yeah,
that's another thing. Like, are front ends even going to be a thing in the future? Like, should we be embedding things in front ends when it's like harder for agents to navigate? These are all some of the things that are going around in my head.
Yeah, I think they're also going around in my head. We're in this transitory phase in general of like trying to map services in the AI world to like our existing way of interacting with computing. And so the way that I still think about it is, let's say I have an agent that's gonna go and connect to GitHub and maybe export some stuff from there to like a Slack message. So it needs to be authorized for both GitHub and Slack. And maybe like when it does some of that action, it actually connects to another agent, agent B that connects to an external service that also needs to be authorized. So how does that authorization request pipe its way all the way back to the user's client, wherever that user is, in order to approve or deny that request? I still think it's like less of a centralized kind of place where I've configured all my authorizations and more of a like user needs to get notified somewhere. The agent UX may evolve where maybe I have like an inbox or dashboard of all my agent workflows, and some of them may be in pending state waiting for me to authorize. Or it may be like in proc where similar to how, like I get a redirect from Google when I sign in to slides.google.com or something. It may be as simple as that, but it's just a question of like I feel like the first versions of all of these systems should be the user is always in control and is very deliberately giving permission to an AI system to perform an action on its behalf. And in order to do that, they need to be notified and authorize that request. So it may actually look like what Kyle showed of like the browser tab coming up, from some interaction, and then like you actually approve or deny that or ask for more scopes for different permissions. I don't want it to be just like I configured all my credentials and auth somewhere, and then like the agent can do anything with that. That seems a little bit uh, scarier than what I would be comfortable with.
Interesting. So like, yeah, more dynamic on the fly type stuff.
Right. Absolutely. Let me actually share my screen. I know we have only 15 minutes left, but a lot of this actually dovetails nicely into some of the things that I've been thinking about. And Richard, I'd love your thoughts on some of this as well. So a couple of the things that we've been thinking about in terms of more advanced ways of representing agents is one is agents representing agents as MCP servers. I'll talk about this in a bit, but if you think about today, like the agentic interaction happens on the MCP client side. So Kyle showed connecting like a couple of servers to Cursor, and then the Cursor client decides how to use those MCP servers to perform some kind of task. And so Cursor is really the agent in that case. Similarly with Claude Desktop or any other MCP client, the agentic behavior is actually happening on the client side. But we had this idea of like, what would it mean to have agents actually be packaged as MCP servers so that even a Claude or Cursor client can call other agents using the same protocol. And those agents could do more sophisticated things than the MCP servers do today. Like today, the MCP servers are basically just tool calls around single APIs. But what if those like tools were actually agent workflows? And that got us thinking about like asynchronous workflows and long running tasks, because agents do things that may take a while, like deep research style, may take hours or some maybe in the future even days to complete. And so how do you like represent those from a technical perspective? Like where's the compute happening? And so we've been thinking about that with MCP Agent a little bit. And for those who are not familiar, MCP Agent is basically this library we've been working on for making it easy to build agents with MCP servers. And we're very opinionated about this idea that MCP is going to be the de facto standard with which we connect LLMs to like tools, resources, data, prompts. Basically, how we connect the LLMs to the world around them is going to be through Model Context Protocol. And so that's where like what got us thinking how far we can take this. So one of the things that we've been thinking about is this is the diagram representation of what I was just talking about, where an agent workflow can be represented as a server itself. And then in terms of authentication and authorization, the interesting question is, let's say like agent server C in this diagram needs some kind of authorization from a user in order to complete its task. So how would that like auth request work? Because it would have to be piped all the way through back to the client side for the user to actually authorize or deny that request. But it's going through another agent in this multi-agent ecosystem. And I know, Richard, you've been like thinking about decentralized AI quite a bit. So this is one of the things that's still an open question for us. We haven't like fully solved that yet. But my hope is that all of that communication can happen over MCP and through the MCP spec and the MCP auth spec and OAuth and so forth. It's just an open question of like how exactly that would work in this like pass-through way. So anyway, Richard, any thoughts on that or any perspectives you have on some of this?
No, I think it sounds great. Like this is a problem that I guess we haven't dug into that much. Kind of these like how you can chain these different agents and that sort of thing. So yeah, very curious to hear what you're thinking about.
Yeah, I'll do a quick demo in a sec as well.
Point.
The other thing is like the cool part about why you would represent agents as MCP servers is then you can like interact with them in this any MCP native client. And my bet is that like every line of business application in the near future is going to be an MCP client. And so to use your agents and reuse them across like any kind of client, it makes sense to represent them as servers. So I'll actually show this demo of like using building an agent and then using it in Claude Desktop. And then the last thing that we've done is added temporal support for like long running tasks and also from like more production grade kind of durable execution style guarantees. And the idea behind that is simple, which is, like it's okay to run things in proc in Claude or Cursor or something like that. But a lot of agent workflows are actually much longer running. I might like go for a coffee break, turn off my computer, and come back and I want like my agent to have done something interesting. And so like the execution backend for it is more similar to workflow orchestration systems than it is to like just in process kind of execution. And so that's how we've modeled it. But like the combination of agents as async workflows and agents represented as MCP servers is basically what we've added to MCP agent recently. So let me actually show you what that looks like. So here I have this thing called a basic agent server. And one of the things you'll note is it has this like, basically it's representing this agent as a workflow class. And the class has a run function. So this is basically like your main application code for your agent. And the agent basically you can actually have sub agents here. Each of them is doing something specific. So in this case, there's an agent that has access to the fetch and file system servers. It can list tools like basic stuff, generate some like do a code completion based on some given input. And then in this case, it's also doing a follow-up by summarizing the previous response in a tweet. So it's like a very basic kind of agent. And then I have the second workflow, which you can think of as a separate agent that basically is used to grade a student's short story. And here it has like a proofreader, a fact checker, a style enforcer, and then it like it gets an input story and it generates a report. And then all you kind of have to do is call create MCP server for app, and this will create an MCP server that you can run on standard IO or SSE or streamable HTTP, what have you. But it will basically package up all these workflows as tool calls. And so what that looks like, if I open MCP Inspector for this, and let me list the tools again. So you can do like workflows list. That's one of the tools. And so you can see there's the basic agent workflow with its description, as well as the parallel workflow that does the student short story submission or grading. You can also like list the workflow runs, which are all the executions of different workflows. You can run a workflow. You can pull for its status. You can resume a workflow, which is like for human input or like human agent interactions. That's pretty important because the workflow may be paused, waiting for either authorization or some kind of feedback from a user. You can cancel workflows, etc. And so like the way we've modeled the MCP agent server is as async workflow tasks that are exposed as tool calls. And then if I want, I can actually like connect this to Claude. So here I have my like Claude desktop config file. Just like any other MCP server, I can like call this. This is running over standard IO. And this is the same one that I showed you before. And so in here, I can actually like see that it's connected to this basic agent server and it has access to these different tools. So I can ask it like list the tools available from basic agent, and Claude basically figures out what's the right like tool to call. And this is the live demos, and Claude 4 just came out, so it might take a minute. But it basically like calls that and figures it out. And then I can also ask it to like run something. So I can say grade the student short story with basic agent, and then I can give it like some short story that I actually generated from an LLM. And this should actually like call the parallel workflow, and it's like using the right thing to invoke it, and it'll actually pull for status and do all of that. I ran this before, so you can kind of see how it like generated the report, and also like gave a grade and generated like uh, the summary for the graded report, etc. But basically, I'm interacting with an agent workflow that has a very specific way of encoding like how I want the short story graded. It's almost like an app or a script, and I'm interacting with it through an MCP client here. And then the other thing that is like for more long running tasks is the temporal support. So here I have like, again, this I have this orchestrator thing, which is a simple, like, again, this student short story grader agent. And here I give it like a very arbitrary task. In this case, I say like load the student short story from that markdown file and then generate a report across different criteria. And for like style guidelines, use the specific style guide from the APA style guide from this URL, and then finally write the graded report to this markdown file. So it's a fairly complex task. And what we're doing here is actually running this with temporal. The cool thing is all you change is like the execution engine from async IO to temporal, but the actual like code for your agent stays the same. Like it's still a workflow, it still has a run function, and it still like defines all your agent logic here. And then I can run it. And if I run this, I have temporal set up here. So you can actually see the workflow execution happening dynamically, where the first thing in this case it's actually going to do is it's going to figure out the plan in order to accomplish this very arbitrary task. And so it figures out, like, here it's a little hard to read, but in this little box here, you can see the first thing it says is it's going to load the student short story from the markdown file and use the Finder agent for that. Then it's going to generate feedback and use the proofreader, fact checker, and style enforcer. And then finally, it's going to compile the feedback into a graded report and write it to disk using the writer agent. So it all looks correct. And then it's like a dynamic workflow execution because you don't know the shape of this execution graph ahead of time. It's dependent on what you ask the agent to accomplish. But the cool thing is, because this is with temporal, I can like cancel this workflow. I can pause it. It can be resumed. It can be signaled with additional information. If the server that was running this failed, I can like spawn it again and retry it, or resume it from where it left off. And so all of those like production grade guarantees that you expect for long running workflows are available if you represent agents in this way. And then obviously, like if I really want for it to be very quick and in proc, then I can always switch it from temporal to async IO. So the open question here is still like, how do you authenticate, authorize, pause, resume for those kinds of more sophisticated like user interactions? But I think like the architecture seems to be right in our minds, which is the agent is going to be this long running task. In this case, it's kind of like finished executing. So there should be like a graded report.markdown file, which it generated. And you can kind of see it generated things across proofreading, factual consistency, style adherence. So it generated a like report on the short story, which is exactly what I asked it for. And you can like observe the logs and see exactly like how it went about doing it. But yeah, this is like how we're thinking about representing agents as on the server side of MCP. But yeah, I'm curious if like folks have thoughts on this as well.
So cool.
Yeah. Can I provide some input?
Please.
Okay, so like I have 2 monitors and a laptop, right? And I often put like 4 co-pilots on each monitor. So you can imagine like sometimes I get like authorization fatigue. Can I do this? Can I do this? Can I do this? You know what I'm talking about?
Yep.
And so that's kind of like a user experience pain point. And to some degree, like I was at the Linux Foundation about a year ago saying, yeah, we need like app stores for AI. And then we need to have like this authorization scheme. And I laid out all this to Linux Foundation a year ago, and they're like, no, we're just gonna duct tape and glue Docker containers together. It'll be great. But yeah, the thing that I've been doing lately is I have this repository called Swiss Knife, which is sort of like Cloud Code. And like I said before, I have like the virtual file system idea to do some isolation. And for the orchestration, I stole the idea from Graph of Thoughts so that I can sort of parallelize as many agents as possible. And I think that what I've said to other people in the past, and this has been more relevant to the people who love blockchain and AI, is like, I used to say like, yeah, I'm going to totally wait for global consensus before like I work on this little task here. Like that's insane, right? Like, and the more like of a hierarchical system you have, the more of a bottleneck that becomes when you try to do anything like big data. And instead, like I never seen like a bee swarm or like a hornet's nest or something use like a blockchain. And to some degree, it's the same thing with like a top-down authentication scheme. It's not maybe a blockchain per se, but like if everything has to rely on some central thing to have attention, that attention is not scalable, right? So instead, the individual agents need to have some reason to do things or not do things. And so the long running project I've been doing is to like translate the entire legal corpus into domain specific first order logic called deontic logic, which has to do with like whether or not you're obligated, permitted, not obligated, or not permitted to do something. And then make like the entire law sort of semi-computable, given that humans are not very good at writing coherent text, and there will still have to be some ambiguity to resolve, but at least to get it into a computable format. And you could literally create like a deontic logic system where like the language model, the language models that exist today can and do, they are capable of using deontic reasoning. So if you had this deontic reasoning architecture about the permission space of certain things, like, you know, I don't want you giving my social security number out, but if someone asks you for a cute emoji, it's okay, right? You know, you'd have like some map of
Interesting.
that are allowed, right? That would be in like your rules file or whatever you call it inside of your Claude code. That would then give it the idea of whether or not to pass to another agent the delegation token. So like I mentioned, you can, and it's about like having delegated access permissions. So like if you imagine like an IPFS, I'm not even sure you know what IPFS is.
But
you could represent like a content ID, and you could also delegate tokens to individual content IDs and even action on the individual content IDs, because UCAN is pretty open-ended. The only problem is
I actually think that's really so one of the things that makes sense here is also like agents can inherit scopes from maybe like the parent that invoked them in some way. So like you don't have to reauthorize agent 3 if you like that's being invoked by agent 2 for something that agent 2 is already authorized for. But then what you're actually getting at is like maybe more dynamic assignment of auth based on like what the intention for the agent's task is, which is I'm gonna have to read up on deontic reasoning. I don't know what that is, so I'll look that up after.
Immanuel Kant. Do you know who that is?
Yes.
Okay, so I think Immanuel Kant.
I see.
And so the philosophers of his day decided that like the laws should sort of follow this sort of premise, or this legal premise of like how you construct a legal corpus, right?
I see.
But that's
interesting.
Like that's the ideal. That's like the Platonic idea of how it should work. That's not how it works in reality. In reality, people are poor at even writing, you know, like to-do lists, and even their to-do lists will have ambiguity. So like, you know, so there's that whole rabbit hole. But the point with the UCAN thing is I think you could do this whole delegation and scoping thing with UCAN. But the guy Dave Grantham at libp2p, and oh yeah, by the way, the guy what is his name? The guy that runs Protocol Labs was telling me that he would love to see libp2p be an MCP server service or networking protocol. I think
Interesting.
I think it's Juan Benet, if I'm not hallucinating. But yeah, so the entire premise was that Dave Grantham thinks that there's no decentralized PKI yet for UCAN, and DID. Just having DID is cool, but DID is not enough because you're going to have to interact with strangers, and once you interact with strangers, you then decide that you need PKI again.
Right.
You do decentralized
Interesting.
PKI.
So
Thanks for
Matt,
sharing all that. Yeah.
I'd love to
Go ahead, Richard.
I'd love to dig a bit deeper next time on another call about how you use the workflow orchestrator, like how you define the tasks and that sort of thing. Like, is the task the whole agent, or do you have like separate tasks? I don't know if they're called tasks
how I do like so I do like graph of thought to do the decomposition, and then task delegation is like based on a Merkle clock, and the Hamming distance between the peer ID and the Merkle clock head just delegates who's the person who's responsible for the job. And if there's no response in the pub sub, then everyone knows that this person is lazy, and then adjusts their reputation score. Like there's no blockchain. It's just I keep a reputation score when I notice that someone else is not doing their job.
I think Richard was referring to like the demo orchestrator that I was showing, right, Richard?
Sorry.
Yeah, I mean like tasks.
Oh, no worries.
Orchestrator sense. I actually don't even know if they're called tasks in Temporal, but that's what they're called in Kubeflow pipelines, like one step in a workflow, basically. I'd love to figure out, like, do you like dynamically define them as you make calls to LM or whatever? That would be really interesting to dive into next time.
Yeah, let's do that next time. The TLDR, just as maybe a placeholder for this, is Temporal has this concept of activities, which is tasks, but basically anything that's non-deterministic should be an activity. So if you interact with an MCP server or an LLM in any way, that's a non-deterministic operation. So I package those as tasks, but there's a lot more there. Like the LLM can generate its own plan. Some of those things may be deterministic, others are non-deterministic. So it's actually like fairly complex on how you break that apart. And like the workflow graph that you see in the temporal side, it may not exactly be the agent execution graph, because the workflow graph is actually like a little bit more lower level than the agent execution graph. So lots to dive in there, but yeah, that's a fascinating long discussion
that's
in itself.
Yeah. Cool. Yeah, some really good, interesting stuff. I'm really glad I got to see your demo of the long running stuff. So yeah, looking forward to diving into that next time. And yeah, I think like having a longer conversation about like auth between your team and ours would be really valuable as well. So
absolutely,
really
let's do that. Yes, great to see everybody, all the Richards on the call and the real Richard. And until next time, take care, everybody.
Thanks so much.
Thanks,
see you,
Richard.
Kyle. See you, everyone. Bye.